In this video, we're going to be looking at how one can identify the type of solution found on reference table G. To begin, when we look at reference table G, we're going to notice a series of lines called saturation curves. If you have an amount of material that falls directly on one of these saturation curves, we call this solution saturated, which means it has the max amount of dissolved material in the solvent. If your value is underneath the saturation curve line, we call this unsaturated, which basically means you have not put enough material in. You can also see that there's another spot on this graph called supersaturated, which means that you've added way too much solute to your solvent, and most likely you're going to be noticing that some of the material has not completely dissolved all the way. Using our reference tables, we can see that table G shows many different types of chemicals when dissolved into water and their solubility. We're going to be looking at the blue line, which is for sodium nitrate. Now, if you want to dissolve 100 grams of sodium nitrate into 100 grams of water, you can see exactly what we're doing on the screen, and you'll need to make your water's temperature about 35 degrees Celsius for it to fully dissolve. Now, at that temperature, only 100 grams can completely dissolve. What happens if we want to add less? If we were to make a saturated solution of only 80 grams, well, we would need to have our solution at roughly 10 degrees Celsius. Noticing that as our amount of solute changes, our temperature is also changing as well. But now let's say we want to add even more material into our solution, like 140 grams. If we did that and we traced the line all the way down from the saturation curve, you would see that the temperature of the solution needs to be around 72 degrees Celsius. Because of the different temperatures, different amounts of materials can be dissolved into our solutions. Sticking with sodium nitrate as our main example, let's pretend we have 105 grams of material that we want to dissolve in 100 grams of water. We can see if we start at 105 and draw a straight line to the right until we hit the saturation curve, the temperature of the water would need to be 40 degrees Celsius for this to be a saturated solution. Now, what would happen if we were to change the temperature and let's say drop it all the way down to 10 degrees? Well, we still have 105 grams of sodium nitrate dissolved into our solution, but you can see this puts us in what we call the supersaturated range, meaning because of the temperature, there's going to be some precipitate that will form on the bottom of our beaker. What if we were to change also the temperature and bring it up even higher? What if we were to change it to, let's say, 70 degrees? 70 is way hotter, meaning the particles are moving way faster in a water sample. So we can clearly see that this temperature, we're going to be at an unsaturated solution. This means we could actually add more of our dissolved solute into the water to eventually make it saturated. Still using reference table G, let's try a new chemical, which is going to be called ammonium. Now we can see that NH3, if we have 50 grams of it in 100 grams of water, what kind of solution would we have if we only had a temperature of 10 degrees? If you find the 50 on the y-axis and 10 on the x-axis, you'll see our blue dot is in the pink range, which means that our solution would be unsaturated. Now, if we kept the same amount of material in water, but then changed the temperature all the way to 90, you can see represented by the pink dot that now we're in the other side, being supersaturated. This means based on the temperature, we have way too much material in our solution and it's going to be precipitating out. And what if we were to now change our temperature to exactly 25, which we can see with our green dot? If we fall directly on that curve, specifically for NH3, this type of solution would be saturated.